Good evening, everyone. This is the Deep Reinforcement Learning webinar, and the topic this evening is the final project of the course. It's cooperation and competition. The environment is basically teaching an agent to play tennis. So I think the webinar this evening actually will probably be pretty fast because a lot of this material we've already covered in some of the previous topics of earlier projects, and a lot of the information is the same as what we covered in other project descriptions. So with that, let's go ahead and get started. So project number 3, the tennis environment. And this evening, we're going to talk about the project itself, what the environment looks like, and some hints on how to solve that environment. And then similar to previous webinars on the other projects, I'll highlight some of the things that I've seen as a reviewer of projects that I've had to turn back to get some additional work done. And if you want to pass on the first submission, follow these hints, and you have a much better chance of success. And I'll have to say, every almost without exception, projects get turned back not because they didn't meet the criteria or there's something wrong with the code. It's almost always because the description's in either the report or the README, and so it's important to look at the rubric and understand what's expected, so that you check all the requirements in those rubrics and cover all your bases there. Okay, let's talk about the project itself. This project, you have 2 agents, and you basically teach them to play tennis. There's a tennis court with a net across it and a couple paddles. The paddles are your agents, and you control the up and down, left and right locations of the paddles, and front and back are the actions. So a ball will fall out of the sky, and the first agent has to maneuver the paddle so that it strikes the ball and knocks it over the net, and then the second agent has to sense the location of the ball and move its paddle appropriately and strike it back over. So it's kind of a more complicated version of Pong, if you're familiar with that very early video game. Because here it's a more of a 3-dimensional playing field instead of a 2-dimensional like you'd have with Pong, but otherwise very similar. So the reward structure, if your agent knocks the ball over the net and it lands on the playing field on the other side of the net, then you get a 1/10 of a point reward. If you don't hit to strike the ball, if it just drops and you don't hit it, or if you hit it and don't make it over the net, or if you hit it over the net but it goes out of bounds, then you lose a reward in those cases, and the negative reward is 0.01. And you need a score of 0.5 over 100 episodes to solve the environment. So that's the basic structure of the setup for the environment. So some hints on successfully completing this project. Almost every student, I wouldn't say everyone, but probably 95% of the students solve this using the same project baseline that they used for Project 2, the same code baseline as Project 2. Most use the Deep Deterministic Policy Gradient, DDPG, and a model that may or may not have batch normalization, and pretty much the same DDP agent code library. So if you were able to solve Project 2 really with very few changes, you just apply it to this new environment and let it run, and you probably will be able to solve this environment as well. So one change that I would recommend if you didn't do this in the second project is to do a version of DDPG called multi-agent DDPG, or MA-DDPG. We talked about this in the last webinar, I think. The main consideration here is use 2 agents, one for each player, but have them share a common replay buffer so that they can each learn from each other's experience. If you just instantiate 2 independent agents and they each have their own independent replay buffer, then you really expect to maybe take twice as long to train, because you're only going to experience half the number of experiences to look at that you would otherwise have if you share that experience. So go ahead and share the replay buffer. Now, the original version of multi-agent DDPG only shared the replay buffer in the critic, so that the agents would be able to work independently after they've been trained. That's not totally necessary in this particular example. You could actually share that replay buffer with both the actor and the critic, but at least with the critic for sure. So as always, I would suggest starting with the Udacity workspace and no GPU. You probably will want to switch to GPU mode once you have all the kinks worked out. This particular environment is not an easy one to solve. Whereas you probably found with between 300 and 400 episodes in the previous project, you probably were successful getting that agent to solve the environment. This particular environment is more complex. I would expect to see you take 2,000 to 3,000 episodes, so maybe 10 times as many episodes. Now, one difference is, the episodes in the reacher environment were really pretty long. The ball would go around the robot arm many times, and it might take, I don't know what it would take, 10, 20, 30 seconds per episode. Here, a lot of times the ball falls out of the sky, and until the agent learns something reasonable, you end up with a lot of very fast episodes where the ball just strikes the ground, you lose the reward, and the next episode starts. So the done flags will end up getting set quite often in this particular project. But still, so the 2,000 to 3,000 episodes sounds like a lot, but you can expect that those 2,000 to 3,000 episodes probably won't take any more clock time than the 200 or 300 episodes on the previous project. But as I've mentioned in previous projects, I really would encourage you to rehost this to your local environment. It's certainly not necessary. It's not required. You should be able to pass this project just like the others totally within the Udacity workspace, and that's fine. But after this course is over, it's good to have had some experience working on your own computer in your own environment. That's what you're going to use if you ever make use of this material on another project, or if you want to experiment with just playing around with other things you see. You're gonna have to rehost that anyway. So I would encourage you to get that experience and run it on your local environment. So once your agents have solved the environment, it's time, as always, to prepare your submission. As I mentioned a few minutes ago, almost always everybody has an agent that successfully solves the environment, and the code is usually a very standardized code base, so usually you don't have any problems with the code. And so where do the problems arise? If you're gonna have any problems at all, it has to do with the other files that you submit, either not including checkpoint files or not having the information that's required in the README and the report. So as always, review the rubric very carefully. This project follows the same basic structure as the previous two, so you're probably already very familiar with what's going to be required. But just to make sure you include everything, this includes in the README file the dependencies, explaining how you load the machine learning agents library, and I have reacher environment here that should be tennis environment. As well as don't forget to include installing all of the standard Python dependencies that you use. I would encourage you to put those dependencies in a requirements.txt file. Again, it's not required, but if you have this in a GitHub repo, and anybody does, you do share this with anyone that might be interested in looking at what you've done. Having a requirements.txt file is just good practice. Makes it much simpler for anybody that uses your environment to get up and running and start with where you left off. Again, on the report, check to make sure that all the items are addressed. And I think this next slide will talk about some of that. The rubric's very clear on everything that's required. I'll have to say that the number one reason the projects get rejected is this one statement of clearly describing the learning algorithm. That doesn't mean just state that you used DDPG or MADDPG and then providing a link. You need to do more than that. So describe in your own words the key features of that algorithm. And as before, I've kind of just mentioned a few things here. Using the neural network as a function approximator, that's sort of the hallmark of deep reinforcement learning. That's what separates deep reinforcement learning from other types of reinforcement learning. We have a couple neural networks here. If you're using DDPG, you have an actor network that is a policy approximator that selects the action based on the state of the environment, the observations. And then there's a second neural network, the critic. So describe how the critic is a value estimator neural network. Talk about the experience replay buffer. If you're using the MA version, the multi-agent version of DDPG, emphasize the fact that you're sharing that experience replay buffer between the two agents. And then, you don't have just a single actor and critic, you have two of each of those. So talk about the soft update process, what that's about, and how the local versions and target versions are updated. And so those are the key things. If you talk about those things in your own words, describe what they are and how they, are the key parts of your algorithm, then that should satisfy the clearly described section. So don't just provide a snapshot of pseudocode. Don't just provide a link. Actually, write a couple paragraphs describing those key features. That's what's expected there. So submitting your project. Again, you've gone through this all before. It's really the same as what you've done in the previous projects. Create a zip file, include your notebook or your main Python file, any other code. I just reviewed a submission earlier today, actually, that had the main file but didn't include the model.py or the DQ and agent.py files. So you do need to include your entire code base for the code that you depend on to solve your environment. Include your README file, your report, and then the state dictionaries for your checkpoint files. Excuse me. And this doesn't happen too often. Excuse me, let me back up. This doesn't happen too often, but occasionally I'll get a zip file that's 150 megabytes that has every project and every mini project and every piece of code that the student has written for the entire course, and then expect the reviewer to find the particular project files within that large repo of everything that's ever been done. Please don't do that. Just go to the project folder that just contains the files for this specific project and zip up just that information, please. So once you submit your project, a reviewer will get notified and take a look at your work and provide some feedback, good or bad. They'll check every item in the rubric, make sure that you've covered all the items, and anything that's missing, they'll let you know what you need to work on to correct that. So if there are any items that are missing, please just take another stab at it, review what the reviewer commented on, and make those adjustments and resubmit. Okay, that's it for tonight's webinar. And this may be the last webinar of the course. The course, really the last project is due this week. And I'll just let everyone know that although the project is due this week, if you haven't completed the project, you do have another week or two after the due date to submit it. The course itself doesn't end until about the middle of the month. And then, as you probably know, maybe you don't, but if you don't complete by the deadline, Udacity automatically gives a 4-week extension. So from today, you probably have 5 to 6 weeks to get everything done. But please, if you still are working on project 2 or 3, wrap those up, and you put a lot of time and effort into the course. Do the last steps to complete these projects and complete the course and get a certificate at the end. You deserve it with all the work you've done. So I've enjoyed working with you all, and good luck on the final project. Bye.